Friends, I welcome you to my YouTube channel MacPM. In today's video, we will study about the projectile motion. You will see there are various types of problem in projectile motion, like a ball is thrown at a velocity u at an angle theta from the ground, how far it will land, and at what maximum height it will reach, and what time of flight it will carry. So these type of problems can be easily answered with projectile motion model. So let's see. In this video we will derive various formulas for projectile motion. So suppose there is a particle which is moving with velocity v, this is o, and this particle is thrown at an angle theta from the horizontal at a velocity v, initial velocity v. So it will move like this in projectile motion, and this path is called trajectory. So suppose this is landing at A, and this is the maximum height it will reach. This is B, this is C. So we will calculate what will be the maximum distance it will travel, which is called range. We will define it with R. And what is the maximum height h, and what will be the time of flight. So and we will also derive what will be the formula for this projectile motion, what will be the equation of the projectile motion. This is x-axis, this is y-axis. So let's see. First of all, we know the law of motion, Newton's law of motion. We have three equations. V is equal to u plus at first. Second is s is equal to ut plus half gt square, and third is v square is equal to u square plus 2as. We will use these three equations to solve all the projectile motion problems. We can use direct formula which we will derive, or we can use these three equations also. So let's see what will be the value of component of this v. Suppose we are breaking this v into horizontal and vertical component. So this horizontal component will be v cos theta, because theta is this angle from horizontal, and vertical component will be v sin theta. Okay, so this will reach a maximum height of h, and you will notice that if this is the trajectory, so starting from this point, this velocity can be broken away into components at all the points, here also, here also. At the maximum height there will be only horizontal component, then it will move like this, and at the point where it land, it will be only vertical component. So you can see that vertical component is changing like this. Vertical component is going like this from here, here, you can see, then it becomes 0 and it comes back here, you can see. And horizontal component is always in a forward direction. So horizontal component is like this, horizontal component of velocity. So you can see that there are two type of motion. First one is vertical, second one is horizontal motion. So we can consider these two independent of each other and solve the problem. So let's remove this. Now we know that v is equal to u plus at, where v is the velocity, final velocity, u is initial velocity of a particle, a is acceleration, t is time. So in this case v is the final velocity. If we are considering the vertical component, then at a maximum height h at point b, the vertical vertical component of velocity will be 0. So we can put v is equal to 0 is equal to, suppose this is v naught, so that we don't confuse with v naught initial velocity is v naught. So v is equal to, v naught will be 0 at this point because sine theta will be 0. Angle here, particle will move like this, so angle with horizontal will be 0. So v sine theta will be 0 at maximum height. So 0 is equal to u is v naught sine theta. Okay, v naught sine theta is vertical velocity, initial vertical velocity, plus a is acceleration. Here acceleration is working acceleration due to gravity, which is downward. So upward we are taking plus, our coordinates are like this, plus and plus, upward direction plus and forward direction plus, and acceleration is working downward direction, so it is minus g and t. From here you can write t is equal to v naught sine theta by g. So this is equation number 1. Now we have derived the equation for t, time. Now we will consider the horizontal term. Our second equation of motion is s is equal to ut plus half at square. Here you can see that s is, suppose we are considering the x direction, so what will be the s? X is equal to ut, initial velocity in x direction is v naught cos theta plus half, acceleration is 0 because acceleration is working only in vertical direction, so acceleration will be 0. So x will be v naught cos theta. And s is equal to ut plus half gt square. If we apply in vertical direction, then vertical coordinate is y, so y will be ut. Initial vertical velocity is, you can see here, v naught sine theta. So v naught sine theta minus into time minus half, because g is negative here, half g into t square. And here we have derived x is equal to v cos theta into t. V is equal to u plus at, this component is 0. So x is v naught cos theta into t. So t is x upon v naught cos theta. This is equation number 2. And this is equation number 3. We can put in place of t, we can put x upon v naught cos theta. So y will become v naught sine theta into, in place of t you can put x upon v naught cos theta. V naught will be cancelled with v naught, minus half g into t square. So t square is this, x square upon v naught square into cos square theta. So y will become sine x into sine theta upon cos theta is tan theta minus half g upon v naught square into cos square theta into x square. So you can see that this is the equation in y and x, and this is the equation of this projectile motion. And you can see that this is equation of like y is equal to ax plus bx square. where A is tan theta and B is this component. So this represents the parabola. So we can say that the equation of the projectile is a parabolic equation. Okay, in next video we'll solve the various problems based on this equation.